In this slide, we are going to learn about how to find the length of an arc which the size of the angle is given in terms of radians. So we can measure the angle in terms of degrees or in terms of radians. If the size of the angle is given in terms of radians, we can't use C equals to 2 pi r. Instead, we use S equals to r theta for you to find the length of this arc. The shot put throwing area on a school's sport field is formed from the sectors of two circles with center C. Angle ECF is 40 degrees and the figure is given below. Calculate the perimeter of the shaded region. So the perimeter of the shaded region is D to G, G to F, F to E and E to D. We have two straight edges. So we know that each edge is 8 meters. But we have to calculate the length of the curved edge EF and DG. Firstly, I will calculate the curved edge DG. That's this minor sector. So when I calculate the length DG, I'm using the angle in terms of degrees. Therefore, 2 pi r multiplied by 40 degrees over 360 degrees give you the length from D to G. My simplified answer from D to G is 1.4 meters. Then I will calculate the arc length EF. It is the same sector with a different radius. So the radius is 10 meters while it's the same angle 40 degrees. So the length from E to F is 7 meters. Now we are asked to calculate the perimeter of the shaded region. So from E to F, it's 7. F to G, it's 8. G to D, it's 1.8. Sorry, D to G, it's 1.4. And D to E, it's 8. So the perimeter of the figure is 24.4 meters. Look at this figure. The diagram above shows the sector OAB of a circle with center O, radius 9 centimeters and angle 0.7 radians. You are asked to find the arc length AB. So when you are finding the arc length AB, you have to use the formula S equals to r theta because the size of the angle is measured using radians. Such S equals to radius here is 9 centimeters multiplied by 0.7. The arc AB is 6.3 centimeters. An emblem as shown in the diagram above consists of a triangle ABC joined to a sector CBD of a circle with radius 4 centimeters and center B. The points A, B and D lie on a straight line with AB equals 5 centimeters and BD equals 4 centimeters. Angle BAC equals 0.6 radians and AC is the longest side of the triangle ABC. Show that angle ABC equals 1.76 radians correct to 3 significant figures. So that they want you to show the angle ABC. That means this particular angle over here as 1.76. So for you to do this question, you have to know the sine rule very well. If you don't know the sine rule, you can have a reference to it that I have displayed it over here. And you have to learn about it, practice it with some other questions, and then apply it over here for this question which is relevant for radians. So here I use sine rule. I take sine 0.6 here and I take sine x here. So what I do, 4 divide by sine 0.6, x is the angle over here. So it's 5 divide by sine x. You have to know how to apply the sine rule correctly. You have to practice sine rule separately before you do this sum. And when you simplify this, x is equal to 0.78 radians. So the angle x is equal to 0.78. We know this angle x is 0.78. We know angle A over here, it is 0.6. But we have to find the third angle over here in this triangle. You know angles in a triangle add up to 180 degrees. In terms of radians, angles in a triangle add up to pi. So pi minus 0.6 plus 0.78 is the value of the angle ABC. That is 1.76. The shape BCD shown above is a design for a logo. The straight line DB and DC are equal in length. The curve BC is an arc of a circle with center A and radius 6 centimeters. The size of BAC is 2.2 radians and AD is 4 centimeters. You are asked to find the size of the angle DAC in terms of radians for 3 significant figures. Before that, I am going to find the length from B to C. So B to C, it is a curved edge. If you want to find the length of a curved edge, you have to use the formula S equals to R theta. So you can see theta, the size of the angle is 2.2. So 6 multiplied by 2.2, that is 13.2 centimeters from B to C. Then I want to find the angle DAC. You can see that angles at a point is 2 pi, which is 360 in terms of degrees, 2 pi in terms of radians. DBA triangle, that is, we say this triangle, DBA triangle and DCA triangle. So these two triangles are similar triangles. Why do you say they are similar triangles? You can see this length BA is 6 centimeters, CA is 6 centimeters. AD is 4 centimeters and it is common for both this triangle and this triangle. You can see that DB and DC are also equal in length because both of it starts from the same point and it meets after 6 centimeters from center A, after 6 centimeters from center A at B and C. So you can clearly see DC is same of its length with DB, AB is same of its length with AC, AD is the common side. So we have two triangles which are similar. Therefore, angle ADC that is BAD angle is same as angle CAD. That means this angle over here and here it's equal. So what we do, we take 2 pi and we subtract 2.2 from it, divide it by 2. Then you can get the value of each angle. What you do, you take 2 pi. From 2 pi, you subtract 2.2. Answer, you divide it by 2. Then you get the value of each angle. So the answer is 2.04. Angle DAC is 2.04. This question is for you. I have not worked out the question, so you can try your question. For you to find the length BC, you have to use S equals to R theta. And you're asked to find the perimeter ABC. For that, you can simply add the lengths of 3 sides. Because A to B and A to C are 2 straight edges, A is the center. Therefore, AB and AC are the radius, which is 7 centimeters each. S equals to R theta, theta 0.8 in radians gives you the length from B to C. So simply adding 3 values, you can get the answer for part B, which is the perimeter of ABC. In conclusion, when you're doing these circular measure questions, you have to know Pythagoras theorem. You have to know the trigonometric ratios. You have to know the sine rule. You have to know the cosine rule. So these things you have to learn separately as separate lessons. And you also learn about these things in your general maths, not in additional mathematics. So if you don't have a thorough knowledge in these areas, you will find the circular measure questions little hard. Therefore, before you proceed with the circular measure lesson, please follow the basic knowledge regarding Pythagoras theorem, trigonometry, sine rule, and cos rule. I will continue with the next presentation. Keep me subscribed. Also, for any information, you can contact me. The number is given.